We are group 16, and today we will talk about the strategy against role in daily life. We have three members in our group. The first is me, Yang Ziqing, and the last one is Lin Pongjing, and the last one is Ren Zhenhui. Uh, okay, this is a zero-sum game where rock beat scissor, scissor beat paper, and paper beat rock. The result is win, lose, or draw. There is no pure state strategy. Not any fixed choice can be used by the other player. The stable solution is a mixed strategy when each action is chosen with equal chance. In real play, people often show pattern and habit, so learning and adjusting strategy is very important. Part B is the supermarket queue game. In this game, two players choose between cashier, normal yearly cashier, and the self-service cashier. The yearly cashier has a slower start, but is faster per hit. Self-service start quickly, but is slower per hit. Player one move first, and player two can observe. The rollback equilibrium shows that the first mover usually takes self-service and leaves the slower option to the second mover. This shows the first mover advantage, but also that the second mover can use information to reduce the loss when there is uncertainty. And about division of the work, Lin works on the rock paper scissors roll, and analyze Ren Zhenhui works on the supermarket queue collection and the games tree. And me, Yang Qing, is responsible for the outline and change charter of eating check logic and making the chart and layout clearly. And about the time management, we plan to finish first draft with 14 days. Week one is for planning and division. Week two is for writing draft. Week three is for the combining. In the final 2 days, we will publish and check academic rules. If there is any delay, we will adjust the work and use the buffer time to make sure we finish on time. Thank you.
In this simultaneous game of rock, paper, and scissors, the laws are rock crushes scissors, scissors cuts paper, and paper covers rock. Each of these strategies has the probability of one-third of winning, losing, or drawing with respect to the choice made by the opponent. In the payoff matrix, win gets you 1 point, loss loses 1 point, and draw gets you 0 point. We read this table from left to right and then from top to bottom. For example, if you threw a rock and the opponent threw paper, you will lose 1 point and the opponent will win 1 point because paper covers rock. In another example, if you choose paper while your opponent chooses rock, you will win 1 point and your opponent will lose 1 point. This is because paper covers rock. The rock, paper, and scissors game we play as children is not as random as it seems. There are strategic moves and payoff optimization in three different ways. Firstly, pattern recognition, watching, predicting, and countering iterative decisions by the opposition. Secondly, mind games, using provocations or reverse psychology to set the enemy's expectations. And lastly, adaptive play, modifying the probability based on historical occurrences, similar to a Bayesian update. This logic changes the game from a pure strategy static equilibrium model into a dynamic, repeated game of wits, particularly in the repeated play case.
Hello everyone, my name is Geng Hui. I'm going to talk about part B, the sequential decision part using the example of supermarket checkout. My brother and I each had about 8 items and we needed to choose the farthest line. We found that just looking at the number of people was not accurate. What really matters is how many items the customer in front of us had. For menu checkout, the start time is longer, about 20 seconds, but each item is fast, only 3 seconds per item. For self-service, the start time is shorter, about 10 seconds, but each item is slower, about 4 seconds per item. In the menu line, there were 2 people with 25 and 12 items. In the self-service line, there were 3 people with 8, 9, and 6 items. In this game, the players are me and my brother. One chooses first and the other chooses after. The strategy are H or S. And the payoff is waiting time. The slide shows our decision tree. Here we use waiting time as the payoff. From the calculation, the 2 people in the menu line took 151 seconds and my own checkout would take 44 seconds. The 3 people in the self-service line took 122 seconds and my own checkout would take 42 seconds. If player 1 chose H, the total is 151 plus 44. If player 2 also chose H, the result is 195 and the 239. If player 2 chose S, the result is 195 and 164. If player 1 chooses ice, player 2 chooses H, the result is 164, 195. If player 2 chooses S, the result is 164, 206. So we can see that player 2 will always choose the opposite line from player 1. That means if player 1 picks H, player 2 will go S. If player 1 picks S, player 2 will go H. For the rollback equilibrium, player 1 compares the 2 options. Choosing H means 195 seconds. Choosing ice means only 164 seconds. So the best choice is clear. The final result is player 1 goes to self-service and player 2 goes to the menu. From this we can see the first mover advantage. The first mover can grab the faster line and push the second mover into the slower one. But there is also the second mover advantage. When the 2 lines look similar or if the self-service machine might have problems, the second mover can observe first and avoid the congestion. So in short, when the gap is big, the first mover had the advantage. When things are uncertain, the second mover had the advantage. So in real life, my brother and I did not calculate all this. We just follow our feeling and both choose self-service. In the end, we wait about 206 seconds, which was even longer than the menu. If we had used rollback thinking, the result would have been better. If I was the first mover, I will take the faster line. If I was the second mover, I will wait a few seconds, then choose the opposite side. So that's all things. Thank you for listening.